Hello, this is episode 3 of AI Clash Cont and Cognition Decathlon. How you remember from previous video from episode 2, there we verified and I displayed how instruction following verification of AI can be done using best software verification practices where we perform verification building test cases in the way that actual results simply compared with expected result, and if they match, if condition of comparison matches, test pass, if doesn't match, test not pass. And I mentioned that one of the specifics of AI is that it can be trained to perform some actions, can be trained to pass verification in case this verification is known, open, and so on. So the best practice would be to randomize, to automate and randomize verification in scope to make it agile as much as possible and to generate changeable, agile, not predictable conditions, actions, setups, and things like that. So how it works? Simple Python code. Generate instruction. Instruction contains conditions joined by and operation. So equation generated automatically as well. Then this implements comparison of equation towards conditions in instruction, and if condition is met, then action applied to algebraic result of the original equation, and we receiving some conditional result that needs to be verified to result from LLM or AI in order to compare that test case has passed and following instructions works as expected. Let me try. So this is good, matches rules 2, 3, matches rules 3. Let's double check. If equation contain just to highlight what am I mean when I'm saying that it needs to be agile, randomized, and so on. Randomized set of conditions in each of equation, randomized set of instructions, randomized equations, randomized actions. Let's go. So rules 2 and 3. 2. If equation contains number of operands greater or equal to 4, 1, 2, 3, 4, 5, yes. And operation 5 is not 1, 2, 3, 4, 5 plus. Okay. And non-operand is equal to 1. Nothing is equal to 1. And any operation is not minus, so I have here operations that are not minus, then reduce result by -8. And if equation contains number of operands greater than 2, and any operand is greater or equal to 1, yes, multiple operands are greater than 1, and any operation is not multiplication, so yes, many of them, then multiply result by 2. So we have algebraic result, matched rules 2, then reduce result by -8. So minus 8, it's +8. It's supposed to be 14, 333 something, and then multiply by 2, it should be 28, 6666 something. Notification, so Python has problems with rounding float values. In case you plan to indeed pay attention to automation and randomization, take this into consideration and probably cut floats to some small number after dots, because otherwise you will have problems with verifications. Anyways, so it is possible to do like that for me. Okay, so for AI, it's supposed to be possible even simpler, right? Then here is a number of test cases automated that verify part of this functionality, meaning equation comparison with instructions, and if equation meets all conditions, as I did, by voice, but it needs to be automated for a testing. For that, I need to initiate this class. I need to add an instruction and add an action somehow. Anyways, you anyway need those methods because some instructions or some conditions are too important and you should not depend on randomization. So some conditions could be defined by tester and actions, some conditions can be done automatically, and so on and so forth. Again, this can be hidden from developers of artificial intelligence and large language models in order to avoid or prevent training of artificial intelligence towards passing this test case. So I have specific methods to configure setup. I have a method to perform an action, so equation parsed and compared to does it meet conditions from instruction or not, and if meets, it performs action towards the value. And then we comparing modified results with expected result. So what do we have here? We have here operations with conditions related to operands and operations, positive and negative scenarios that apply to specific position. Exact mean that to operand on position 0, 1, 2, so on. And non-specific, any and none. Positive means equation meets the condition, negative means equation doesn't meet the condition, so operations shouldn't happen. That's simple. And just to it has 120 test cases. It's by accident, but anyways, good round number. And I have a scope of work for artificial intelligence where I define my instructions. I should have specific class name. I should have specific method names. They should apply specific parameters. Those parameters should have specific structure. Some internal variables should have specific structure. They supposed to perform exact actions with each other. They need to update or perform specific actions when executed. I need to be able to call modified result and gain this variable that is class specific variable. Things like that. Pretty complicated, right? Right. So let's see how it works. This scope of work, and let's do it. I will remove, so test case is executed towards file called IF-eval APIs. I remove in this file, my file, oops, and replace it with code that is generated by AI. And run test cases, and let's see. Boom. 104 failed, 16 passed. Everything has failed on assert, so something is treated incorrectly. Not investigating the result, but using my perfect checklist, and let's run. There are no crashes on calling class, no crashes on calling methods, no crashes on using arguments, less than 60 test cases passed, and I don't see anything else that can be treated as a bug, not related, so here is pass. That's how simple it is. Aha, after all explanation is done. Let's run next. And run test cases. Boom. Oh, here is better. 98 passed, 22 failed, all failed on asserts. Let's go. So Cohere. Class name okay, method names okay, less than 60. How many? 98 passed. Okay. 78, 98, it's here. And again, I don't see anything that can be treated as a bug, so no other bugs. Let's move next. Gemini. Same instruction. Scope of work, let's call it. Copy. And running test cases. Boom. 58 passed, 62 failed. Everything is failed on asserts, so problem with processing things there. Let's go. Gemini. Pass. 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 Fail, 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 fail. Again, I don't see anything that can be treated as a bug, so anything besides internal logic of code is not working. So let's go next. Grok. I had a comment that Grok already have this think functionality that allows it to perform better, and this think functionality was enabled during the test, but if this page is not touched for a long time, it reloads and drops all the configuration here. So just for your information, Grok 3 was smart when executed this test. Running test cases, and I have 120 pass. That is amazing, I would say. So I'm sorry, this is not the first attempt to make this video, so my emotions a little bit lower than were first time when I saw it, and I'm not a very good actor to, fake that I'm amazed when I know that I'm amazed. I'm still amazed, but emotions are much lower now. This is amazing. That what I was expecting, but not expecting. I didn't thought that any AI will do this, and any AI will understand scope of work in the way to perform everything that is expected there. But you see, wow. Grok 3 all pass. In case you need something to report about, always verify this thinking chain of thought that AI chat generates. There will be a lot of things that can be treated as a bug, but in this particular test, it's not a scope of testing. And we're moving next. Let chat from MistralAI. Let's go and repeat. Peace. Oops. Boom. 60-60. Interesting. All failed on asserts. Okay. Positive, positive. All positive. So looks like no actions applied at all. This is why negative are okay, because negative not expected. Negative test cases expecting that action is not applied, and all 60 test cases related to applying actions failed. Well, okay, let's go. Pass 60 test cases passed, but I don't see anything that can be treated as a bug additionally. And let's go next. Perplexity. Oh, you saw it. So when page is untouched for some time, it's reloaded. Let's repeat. Let's run. Boom. Much better. So 108 passed, but failed test cases failed not on assert but on type error. So something in instructions related to specifics of representation of variables or data was ignored or incorrectly implemented. So, but anyways, pretty good. 108. Perplexity. Stop. Instructions, method names and arguments. No errors on calling methods. Okay, methods. Calling methods is okay. So this is other. While the chat has, I'm sorry, it was automatical. In Perplexity got the failure because this error is not related to calling methods, to calling class, to processing arguments. It's something internal, something with logic of internal processing of the variables in data. Whew. Pass 108. 99, 108, it's here. But it has other issues related to processing. Reka. Let's go. Same instruction. Copy. And running test. Poof, all failed. Missing one required positional argument condition. IF-eval condition generator, add instruction. So add instruction failed. It treated something was mistreated in the instruction related to the method. So here it fails, here it passes, and all are skipped because none of these cases were executed. No other issues. Well, no other issues. Let's move next. Claude. Copy. And tests. Boom. 120 passed. Nothing to add here. It's same amazing as Grok 3. Yes. I'm writing scope of work in the way that is understood by Claude and Grok 3. Nice to know that. Let's move next. DeepSeek. DeepSeek. Long chain of thoughts. Oh, come on. Copy. And test cases. Boom. 58 passed, 62 failed. Everything failed on assert. So no additional issues. And let's do it like that. Pass 58. And nothing else can be treated as additional issue. So this is more sophisticated, I would say, test for instruction following. It combines instruction following and code development, and actually it is closer to a system test case, because eventually when people developing code, they need not just code, but this code need to meet some specific conditions in classes names, variables names, what else, method names, all things like that, APIs, API calls, all of that. The better AI chat or LLM generates code, API calls and things like that, the better it follows instructions that written pretty good, I would say. The better it is for to be applied for code generation. Here are results. Have a great day.